Ready. Set. Secure.
Hi everyone, welcome back to the episode on Cloud Key Management. In today's episode, we'll be taking a closer look at bringing on encryption as our fifth option in our Cloud Key Management skill. To better understand some of the use cases with this option, I'll be introducing HashiCorp Vault, a secrets management application running inside an AWS IaaS workload to help us compare the different encryption key management options. And at the end, I'll go through a demo showing how Vormetric transparent encryption by way of bring on encryption can help us protect our data at rest using keys that we own and control. So if you're ready, let's go and get started. Starting with, what is HashiCorp Vault? HashiCorp Vault is a centralized secrets management application that helps us merge identities across providers using access control lists to broker access to systems and secrets. It is by this foundation that Vault allows us to centrally manage and enforce access to both our secrets and systems using trusted applications and user identities. In addition to identity and secret management, Vault has been expanding its data protection features, simplifying the encryption of data for both in transit and at rest across different environments. We'll explore more about these features in the next episode, but for now, let's take a look at and ask, what is a secret? When we talk about a secret, we are talking about something that allows us to either authenticate or authorize against an infrastructure, system, or application. Some examples of these secrets might be a username and password combination used to log into a database, or an API token used to authenticate and authorize an action against a service or application. You can also consider TLS certificates a secret, even though they may not always be used to log into a system, but are instead used for both verifying and trusting an identity along with securing the communication of our data in transit. And if any of these secrets fall under the wrong hands, they can be used to access some of our most sensitive data. Sensitive data will be anything you would consider confidential, sensitive, or personal identifiable. For example, your credit card numbers, your social security number, or even your healthcare records, as these are all just a few examples of sensitive data you would like to prevent from falling under the wrong hands. In addition to identity and secret management, Vault can also be used as an encryption key management application to protect your data both in transit and at rest using some of the methods listed here, such as tokenization, format preserving encryption, or data masking. The foundation for how Vault protects our data using any of the methods listed earlier is based on this two-tier key hierarchy. At the time of unsealing Vault, Vault exposes the master key, which is used to decrypt the storage key. It is this key that Vault uses to encrypt our secrets and data before storing them at rest. The security risk with these keys is that they were generated in software instead of hardware and exist in memory in plain text while unsealed. Make sure to continue to follow us to see how you can use your own key, also known as hold your own key, to protect your secrets and data. But for now, let's explore another security threat that is associated with so many other applications similar to HashiCorp Vault. Let's switch gears for a second and take a look at deploying Vault inside an IaaS workload. At the top of the stack is the application layer. This is where a Vault application would reside. As we start to build one of our Vault nodes, we're having to save configuration files, certificates, and even credentials inside the file system our Vault application is running on top of. We are also having to think about where we're going to store our secrets, backups, and even audit logs, among other things. These are all forms and types of sensitive data that should be protected, but the question you might be asking is, who am I really securing and protecting my data from? While most of us are focused on securing the perimeter from external threats, it turns out that our biggest threat to our data in our environment has always been our privileged users that have unfederated access to our data. These include your root and system administrators, your virtualization admin team members, or even your storage backup team members. And now with the shift to the cloud, we're also having to protect our data from the cloud providers themselves. So what can we do? Well, it also turns out that when it comes to securing your data at rest, encryption is the best method of protecting your data, but can also be the hardest to manage. Now let's see how each of the encryption key management options can be used to apply encryption at each layer of the stack. Starting with the default encryption option using an AWS-owned CMK. These keys can only be used for server-side encryption at both the disk and storage layer of the stack. Next, we have our native KMS option using an AWS or custom-managed CMKs. These keys can only be used for server-side or client-side encryption at the application and database layer of the stack. And if we want to generate, store, and be the owner of our own key material, then we can use either a Cloud HSM or an external key source to generate and import our keys using a customer-owned CMK and apply encryption at the same layers as before. With Bring Your Own Encryption, we can apply encryption at the file system, database, or application layer. And with Hold Your Own Key, we can use these keys to apply encryption at the upper layers of the stack. As you can imagine, based on where our Vault application is writing and storing its information, our focus should be to apply encryption at the file system level by way of Bring Your Own Encryption. Introducing Vormetric Data Security Manager and Vormetric Transparent Encryption by way of Bring Your Own Encryption. Vormetric software and key management delivers data at rest encryption with centralized key management, user access controls, and detailed access audit logs that can be extended across multiple environments using a kernel agent base that sits in between the OS and file system. By placing the agent at this level of the stack, we can reduce the risk of exposing our most sensitive data from external and privileged users while still only allowing approved users and process to access our data. Vormetric solution is a FIPS 140-2 certified and can be validated up to level 3. To see how it works, let's jump into a quick demo. Here, I'm currently logged into the first Vault node that is part of my cluster running inside AWS. We can see that I've logged into as a CentOS user along with the IP address of this node, which is 172.31.74.201. If I do a secfs --status guard, we can see that I've installed encrypted and I'm now guarding 2 directories using the Vormetric agent. From this output, we can see that I'm using the agent to control access to both vault/config and also vault/storage, with each path sharing the same encryption key but having different key policies. For this demo, I moved all my vault config files, certificates, and credentials under vault/config, and because I'm running Vault 1.5 along with this new internal backend storage, I'll be writing all my secrets to vault/storage. Now, if I do a sudo systemctl status vault, we can see that Vault is active and running. Now, if I do a vault status, we can see that the Vault node is currently sealed. We'll unseal our Vault node in the next episode using an external key that we own and manage. But for now, let's try to take a look at the config file that Vault is using to run. Now, if I try to cat this config file, well, that's strange. What if we try to use the string command? So if we do strings and paste the same config file, nope, we still get ciphertext. Okay, well, let's try to switch over to the root user and try to cat the same config file. Nope, same thing. Well, I think it's clear now that Vormetric isn't decrypting our data when we try to read it using either the CentOS or root user. Let's jump over to the Vormetric Data Security Manager to find out why. Starting with the host menu from the Vormetric Data Security Manager web console. From this menu, we can see that we have 5 Vault nodes registered and configured to our Data Security Manager appliance. Let's select Vault number 1, which is the second to last in our list of hosts. From this new menu, we can see some additional information about the host and agent running inside the server, but let's continue and switch over to the Guard Points tab. From the Guard Point tab, we can see 2 directory paths we are protecting using the agent and the policies associated with each path. The one we are interested in is the one labeled AWS HashiCorp Vault config key policy, as it is the one that is encrypting and protecting Vault's config files. Let's select the policy to see how it is configured. If you ever had to manage a firewall, the order precedent for how Vormetric processes its security rules is the same, which is top down. You can define a rule based on 5 conditions, based on a resource, user set, process set, action, effect, and time of day. The last rule is our deny any or deny all in Vormetric terms. The rule above is granting privileged admin read access but doesn't have the apply key, which explains why our CentOS user is getting back ciphertext. The rule above shows the Vault operators, which includes me having both read and write access in addition to having the apply key effect, meaning that any users under this user set has access to read and make changes to the Vault configuration files. To see if this is true, let's switch over to another window where I've directly logged into the first Vault node as myself. Now if I try to cat the same config file from here, we can see that I'm able to read it, providing that Vormetric is transparently encrypting and decrypting my data and only authorizing access based on the key policy. Now let's assume one of the server admins knew my username had access to Vault's config directory, which includes the TLS certificates that Vault uses to secure its communication and identity. In the wrong hands, they could be used to intercept and steal secrets. For this next example, let's switch back to the window where I'm logged in as a CentOS user, and let's try to switch to my username. I'll start with switching users by typing sudo su v Mendoza. And now if I try to cat Vault config file, we get the same thing back, which is ciphertext. This just goes to show how Vormetric is able to mitigate and prevent these type of privilege escalation attacks and only allow those that have authorized access based on the key policy. Well, that completes our demo for today. That's it for this episode on Bring Your Own Encryption. In the next and last episode of our series, we'll be exploring hold your own key as the last option in our cloud key management skill using both HashiCorp Vault and Talus. I want to thank you for watching, and I'll see you guys next time.